Hi, my name is Kerry. I'm a Customer Relations Team Member at PowerTech Wireless Technology, and I want to welcome you to our YouTube channel, your ultimate guide to the world of technology. Today, we will learn about MIMO. MIMO, multiple in and multiple out, is a radio access technology that uses multiple transmitters and multiple receivers to communicate multiple streams of data over the same frequency band simultaneously. The demand for mobile data continues to explode with an incredible projected year-on-year growth of 46%. Mobile network operators are continually pressed to find new ways to get more data through the air. There are 4 approaches to increasing capacity without having to acquire more spectrum. All 4 circle round the idea of increasing something known as spectral efficiency. Spectral efficiency measures in bits per second per hertz, refers to how much information can be transmitted each second over a given width of radio spectrum. In even a small town where many be thousands of mobile data users, from ordinary pedestrians to people driving in vehicles to small IoT devices built into advertising signs and vending machines. While a single cell tower may be sufficient to cover this small town, doing so would put each device in competition with each other for airtime. The radio access network would have to then juggle a complicated schedule of who transmit when and how many resource blocks to dedicate to each user. Some users would be far from the cell site and must transmit at a slower rate in order to make sure their information was set successfully. By adding additional cell towers in key geographic locations, the total number of users will be divided between all sites. Each site now schedules a smaller number of users, meaning more airtime per user. This seems reasonably straightforward. However, as these new sites are operating on the same frequency band, they must be carefully positioned and the transmit power of each base station coordinated to ensure interference is kept to a minimum. Adding sites in work signal areas allows users who were originally transmitting at a slower rate and consuming more airtime per unit of data to communicate with the base station at a faster rate and improving the number of bits per second. A common approach to increasing network capacity is employing the use of external antennas for stationary devices. This can come in a few forms, from connecting high-gain antennas to user equipment sitting on the cell edge, to setting up a network to operate in a fixed wireless access mode. This improvement is not insignificant. The difference between the slowest and the fastest, least complex and most complex, transmission schemes is anywhere from 12 to 49-fold increase. This means up to 49 times increase in capacity is achievable simply by lifting users from low schemes to high schemes. Without diving too deep into the topic, at the very basic level, modulation represents the amount of information that can be transmitted in a given unit of time. Modulation efficiency is measured in bits per symbol. During the course of an ordinary communication, a 4G or 5G device will continually change its modulation scheme to reflect changes in the transmission conditions. If the transmission path becomes obstructed by objects or the channel becomes noisy from interferers, the device will alter the base station, which will look up CQI index to determine what modulation and coding scheme matches the newly reported signal quality. Under clean conditions, where signal strengths are good, the channel noise is minimal. The device will operate at the maximum modulation scheme available. As digital signal processing technology improves over time, new modulation schemes become visible. A key advantage of this approach is that often the upgrade could come in the form of software upgrade. The downside is that the new modulation scheme mostly affects those users operating under near perfect conditions. Of course, with some users completing their data transmissions at faster rate, the link utilization is lower, freeing up scheduler resources that can be then dedicated to users suffering slower rates. This brings us to our final approach, MIMO involves multiple transmission antennas communicating with multiple receiver antennas over the same frequency domain. Ordinarily, two devices communicating on the one frequency causes a collision, or at the very least a rise in noise floor. MIMO uses the concept of space diversity to allow multiple transmissions over the one frequency without causing this negative impact. Spatial diversity involves physically separating antennas so that independent transmission paths can be established with the receiver. The simplest form of antenna configuration is called SISO, single in, single out, a device's RF front end connected to a single antenna, which establishes one communication link, referred to as a stream of receiving devices' antennas. This forms a one-to-one relationship between two device antennas. MIMO, multiple in, multiple out, differs to that it uses more than one antenna at each end. Relationship can be one to many or many to many. The most common form is 2x2 MIMO, which refers to two transmit antennas establishing two communication links streams with two receive antennas. It is important to note that the device may choose to not use all antennas, instead constructing fewer spatial streams depending on the transmission environment. This concept is important to understanding massive MIMO. As a partial implementation, some technologies such as 3G use transmit or receive diversity, which refers to using a single antenna at one end and a multiple at the other. The configurations work best in multipath environments where the two antennas can detect and combine signal over different propagation paths. Using MIMO, we can theoretically achieve up to an increase in throughout per antenna. Intuitively, this follows from the ability to add one additional stream of data per additional antenna. Under real-world conditions, however, this is rarely the case. Stay tuned for our second part of the video next week to understand the reasons behind it, when we will look at the major MIMO configurations. Follow and subscribe our social media pages and visit our website for more tech tips.